if you want this photo, get with my people and they'll get with your people, and we'll see what we can do. So, what are we going to do first here? Now, everyone's seen this before. Why is this jumping? We got some Pink Floyd action going on here. Now, this is actual refraction. Let me just state this, that we are not denying the existence of refraction. Okay? That's not what this is about. This is hyper-specific. What we are saying is terrestrial refraction is a fucking nonsense. It's an imaginary, made-up nonsense from somebody or a group of people that made it up that's so incomprehensibly absurd that, and you're going to see that over a few minutes. I'm not going to go into that, but I just like to say here, by the way, which one's pink? You following me? You tracking with me, Sunshines? Yeah. All right. Let's figure out.
Floyd.
Oh, here we go. He's going to start already. What?
No, I was being leery there with Where's Floyd, but the reason terrestrial refraction exists is because in their world, it can see too far and it denies all the physics that they understand. That's why terrestrial refraction exists.
Exists?
The Band-Aid.
Or conjured.
No,
It's conjured as a mental Band-Aid. Yeah?
It's the personification of it's a sphere because it looks so flat.
All right. You're still too low. All right.
It's a sphere because it looks so flat.
That doesn't have anything to do with what I'm getting ready to talk about.
Terrestrial refraction exists because it's not a globe. That's why it exists.
Okay.
It exists because it is a globe. Because it is a globe and I can see the black swan. And why can I see the black swan? Because, contrary to all my understanding, light must bend to allow the preservation of the ball. That's the purpose of terrestrial refraction.
I was asking the question rhetorically.
Oh.
It's a good explanation.
I disagree with Adam.
All right.
It's perfect, Adam. You said it perfectly.
Yeah, he did.
Welcome to my
Yeah, he
world.
shouldn't have said anything because it was rhetorical.
Yeah, so what? I just answer rhetorical questions. Who cares?
I care. Go on mute. All right, let's define this. We're not going to define this monkey. We're going to let them we're going inside their paradigm. We're not attacking this from the outside out of ignorance. We're going to use the subject matter experts to destroy the subject matter experts. You're going to love it. You're going to reach self-actualization here in a few seconds. And then throughout the presentation, it's going over and over and over again. So let's find out what this monkey is. Now, I'm not going to there's a lot of things in this definition, in the first part of these definitions. I'm going to let it go. But I'm going to circle back, and we're going to destroy everything in these definitions. So just be patient. All right. First of all, what do they say? They, as in the subject matter experts, say refraction is. Well, it's real simple. Go find it. From the physics classroom, refraction is the bending of a path of a light wave as it passes from one material to another material. The refraction occurs at the boundary and is caused by a change in the speed of a light wave upon crossing the boundary. The tendency of a ray of light to bend one direction or another is dependent upon whether the light wave speeds up or slows down upon crossing said boundary. That is refraction, ladies and gentlemen. Okay?
Wow.
The formula, not the formula they use, the equation they use is n material equals the speed of light over the reference material speed, right? Over that medium speed. It's the index of refraction, and it's a constant, just to let you know. We're going to be dealing with a little bit with this. I don't want you to overly focus on this because we're going to take it all apart, all right? I just wanted to show you guys what it is. What?
Like, I was just thinking, if you wits it, how do you deal with that sentence?
Yeah, don't worry about that. Well,
no, but do it. If that's the definition of refraction, how do you deal with it if light's speeding up and slowing down when it's not?
It's oh yeah, this definition.
doesn't
Yeah,
have
you got. Well, it depends on what time of the day that you ask them, I guess.
Well, yeah,
What?
correct answer.
Yeah, but light technically doesn't have a speed, right? So
Exactly, but we don't want to go
legally
down that
wrong.
road right now.
But it's a wrongful description.
Well, we're gonna get there. Relax. So,
Hey,
like I
have
said,
to be loud, otherwise I'm not heard.
yeah, I got you.
Sorry.
Yeah, I got you. Just well, we don't want you to be heard just yet. All right, n equals the index of refraction, right? That's what this is giving you right here. The index of refraction. Same thing with this here. N sub 2(1) equals epsilon 1 over epsilon 2. It's what I'm trying to say. It's a ratio, right? That equals sine over the incident ray over the sine over the refracted ray. Don't worry. Don't let this confuse you. All I want you to know, it's a ratio. We're dealing with ratios here, okay? But don't get your panties in a bunch over this. If you don't understand this, don't worry about it. You don't need to, really.
It's important what that ratio is. Just scroll up and show what the ratio is.
What the hell are you
It's the
talking?
ratio of angle of two straight lines.
Yeah.
Yeah? That's the
And
point.
speed not involved.
Ratio is the angular change of the straight lines. There's no bending line.
We'll
Yeah?
get to
That's
that.
what index. Sorry. Okay.
And no speed changes.
We're going to get to that. You guys better shut up.
Yeah.
All right. So just keep that in the back of your mind. We're going to be revisiting that here in a couple seconds. Not for too long, but we'll revisit it. So I'm going to give you the 5-dagger fistful of dipshitteries and then tear them apart with their own subject matter experts. That's what I'm going to do. So, number one, whenever baltards begat refraction, they're unwittingly invoking terrestrial refraction, ladies and gentlemen. Not refraction, terrestrial refraction. You see that little adjective on the front? That changes the game, right? We have the subject matter expert, Andrew Thomas Young, from San Diego State Astronomy Department. He's going to give you a little flavor of what he's talking about here. Listen closely, ladies and gentlemen. The atmosphere is also curved as it follows the shape of the Earth. In the calculations below, we'll adopt a rough value of 6,400 kilometers as the radius of curvature to make the calculation simple. All right, if you haven't seen it yet, let me clue you. This is a necessary antecedents consequent game. This is the consequent. In order for this consequent to exist, guess what else has to exist first? Yeah, you guessed it. The necessary antecedents. Here's one. I highlighted them for you, and here's one. You see the problems with this just yet? I'll go ahead and outline the issues. So, for terrestrial refraction to exist, like I just said, two conditions, that is, necessary antecedents, must exist. You must have curved gases in their paradoxical atmosphere. Remember, atmo means air. Air is a gas. Sphere is a shape. Gases have no inherent shape. See, this is 1A. This is where my prosecution rests, personally. Why? Because of these statements right here, these curved gases. Because if you think gases curve, that is, gases have shape, you'd fail first grade intro to gas behavior. And that's not hyperbole. That's literally from Christy Bodak, Southwestern University. Grade level. I will use this lesson with a first grade class. If an object is in a gaseous state of matter, it will not have a definite shape or a definite volume. So it's all over, just like I said. So, Andrew Thomas Young would fail intro to first grade gas behavior. Literally. So that's not just hyperbole, folks. That's hyperbole. No pun intended. We all know this, right? if you need me to confirm it, I'll do it right here. Chem Liber text. Like liquids, gases have no definite shape. So are you getting it? Christy's not off the reservation here. You have a backup here. We all know this, right? I just wanted to put that in there just to confirm, okay? Let me finish it out. Like liquids, gases have no definite shape. But unlike solids and liquids, gases have no definite volume either. And while I'm here, while we're sitting here and we just read that, to everyone that begocks fluids and think that that word magically makes gases and liquids the same, you need to get frontal lobotomized. They're not the same. They just arbitrarily classify liquids and gases as fluids. Liquids are not gases. Gases are not liquids for quite a number of physical reasons. But I digress. Sorry about that. It was there for me.
But they
Fluid
both
is
flow.
not a definition.
Here we go. What?
Well, just
both
the way
flow.
go on, Owen, you first, and then
I'm just
I'll
saying
go.
they both flow. They're fluids. So they
Here we go. Shut up.
They just want that property and they ignore the things that really makes them differentiate.
Yeah, okay, fair enough. Go ahead, Adam.
No, the point I would make is that fluid is not a definition of a phase.
Correct.
Matter.
Good point.
Gas,
Say that again, Adam. A little louder.
Gas and liquid are phases of matter. Fluid is not. Fluid is a description of the behavior of the phases of liquid and gas.
Precisely.
Exactly.
And precisely. So I hope everyone got that. It's a very important point. I thought of that too, but Adam, thanks for catching up with it. Don't let that confuse you. All right? But that's a very important point. Fluid is not a phase. So let's go to point B. Remember I said I stopped at point A because I can do that. I don't need to go any further. The horse is dead. However, there are many who like the second necessary antecedent, right? And there's no problem with that. All right, so let's go through it again from the subject matter expert, Andrew Thomas Young from San Diego State Astronomy Department. I'm going to read it again. The atmosphere is also curved. Oh, by the way, atmosphere is a paradox. And the reason why is gases don't curve, but I digress. The atmosphere is also curved as it follows the shape of the Earth. In the calculations below, we'll adopt the rough value of 6,400 kilometers of the radius of curvature. Well, everyone knows the problem with that, right? That has to exist. So demonstrate where you got the radius of the Earth from and then validate it. You have to. You have to do it on both. Remember, you have to have both of these because they're necessary antecedents to the existence of their terrestrial refraction. So it's common sense. If these must
measure it. Sorry.
So you have a begging the question fallacy radius wrapped in a contradiction in terms paradox atmosphere. See, I don't even get to B. I just halt at A. It's all over for them right there. There's no way out. You can watch them squirm, right, when I bring this up, and they'll try to get out of it, but I won't let them out of this. I won't do it. I won't chase their idiot red herring fallacies out of it. I just keep hammering them here. But you do what you do, okay? But these two, one A and one B killed. Number 2. Baltards must, listen up, ladies and gentlemen, they must invoke Snell's law. There's no way out of this because the law of refraction is Snell's law. Oh, boy. From their alma mater wiki. Snell's law, also known as Snell-Descartes law, and the law of refraction. You see this little thing right here? You can't invoke refraction without the law of refraction. Duh. But I digress. Is a formula used to describe, listen up, the relationship between the angles of incidence and refraction when referring to light or other waves. We're going to destroy the waves. Don't worry about it. Passing through a boundary between two different isotropic media. They even give you examples: water, glass, or air. Right? We've had Lucy. You have some splaining to do. Every time you look up Snell's law, you're going to see something akin to this diagram right here. All right? And the equation. This is Snell's law for refraction. Everyone take a little look at this. Okay? The diagram first. We got air, the refraction index. Ooh, what's that variable with the subscript? Ni. That's the refractive index of air. And then we come down here and we see water. And that's Nr. That's the refractive index of water. What else do we have here? We have a boundary or surface they were talking about. Then we go up to the equation and say, uh-oh, we have N subscript I. That's refractive index of air, one substance, equals Nr. What's that? That's the refractive index of water. My point being, there's 3 points here. One, the first point, you have to have two different substances and a boundary between those substances. The Atmo has no boundaries, and it's only one substance. So they're in a complete, the anti-flat earthers are in a complete category error. If they would have brought up the recipe for a pineapple upside down cake, it would have had just enough relevance as they say, well, the Atmo that has different densities. That's not Snell's law. I just defined it. And every single diagram will show you it in spades. So it's Mach's next, man. It's over. And we're going to get into...
Don't move that.
Don't move that, huh? Go ahead.
This is what I was talking about earlier. And the claim is that light's bending. Okay, we're invoking refraction. This is what refraction is. Look. I think we're all familiar with what an angle is. See that theta 1, theta 2? They're angles. Now, if the light was coming in anything other than a straight path, we wouldn't
have an angle.
Would it?
No.
Light doesn't bend. It's this boundary change that they're trying to pretend is this bending. Now look at how light will change and refract, continuing in its straight path, refracting in a different direction, is what's being invoked here. Look at what's required, but there's no bending. To get an angle, to define what refraction is, the refractive index, that ratio, it's a ratio of the angles. Angles require straight lines.
Very good point, Adam. As soon as you said theta, I said, I know where he's going. Very outstanding. He is sharp today, folks. Look out. I can tell these things. How many floggings? Not too many, right?
Can I give my very more oversimplistic version?
Very more oversimplistic.
Yeah.
That's a perfect sentence.
Yeah, it wasn't. Right. So, yeah, every time actual refraction is attempted to be grafted into terrestrial refraction explanation, it's immediately undone by the very nature of it, of course. And
you
would require
Arwen,
a
you are
vertical
correct.
Gradient.
But no one can hear you out there.
Oh, okay. Well, you require a, what do you call it? A horizontal gradient, where basically there's different gradients.
Don't you even start with gradients.
Yeah, but the point is there is no gradient whatsoever that is vertical of nature, like into the distance. The
No.
only gradient
No,
that's
that's the opposite of that, and I don't want you going there right now.
Okay.
Just to summarize, Owen, that Snell's law doesn't require a gradient of one isotropic media. Indeed, it's two different isotropic media where this is going to occur. That's the point, yeah? Not a gradient of one.
Yes,
That's
even
the
though they say
definition.
so. Arwen, even though
I'm on about what the definition of Snell's law is, not what the anti-flat earthers say.
Exactly. And I want you to chill out. What your statement was, your first statement was correct, Arwen. I don't want to. I just don't want that released yet. Just relax. You're starting to steal my thunder. Just relax with that.
It's just my basic. Is my volume better? It's
Yes.
basic understanding of refraction. It's just that you have to have that radical difference in medium, and that doesn't exist into the distance, and it would be crazy because could only work one way. It's like it's a complete cluster screw as to the workings of refraction. It can never be made to work like terrestrial refraction.
Yes, sir.
It's physically impossible.
Yes. All right, just hold on to those thoughts. Like I said above, I had this above too. We'll just go over it briefly. The index of refraction, it's the same thing. N equals the speed of light over epsilon. The speed of light versus epsilon is the refractive index of said material, whatever. And it tells you right here. N is the index of refraction. C is the speed of light. And epsilon is the speed of light in said medium. And this is the same slide I had above. All right. It's not don't worry about it. It's just that's the index of refraction. Now, I'm going to do the same thing again, just in a different pictorial. Here we got Snell's law. I want you to focus on what I have highlighted. We have two different isotropic media, air and water, and what do we have in between them? We have a surface. Ladies and gentlemen, gases, that is the atmo, doesn't have surfaces. That's a big problem, right? So it's got to be two different isotropic media. We got N1 and N2 up here again. So they have to be two different isotropic media. Period. Even if I grant them, I'm going to do this. Even if I grant them their idiot conjured, pulled out of their ass, well, it's different density gradients, QE. Really? Can you show me a horizontal density gradient? Listen to Adam.
It's a change in the incidental angle, okay, at surface boundary.
Yes.
Surface boundary between the two different medium. Surface boundary of the two medium. Yeah?
Yes, sir.
There is no surface boundary in one medium's varying gradient.
Exactly.
Surface boundary.
Yes, that's number one. And number two, you guys, these guys have lost the plot. They can't even. Formica is friggin' blushing. Formica has depth than the idiot Baltards. And not the Baltards, the Pretender Clown Flat Earthers. And the hell am I thinking of? Anti-Flat Earthers, sorry. It was right on the tip of my tongue. They don't know any of this. Is just, no pun intended, this is just surface stuff. This is right on the surface, folks. We didn't even get into it. And it's already destroyed from the inside. My wolf pups are loving this. Hopefully everyone's getting this. Yeah? This is the law of refraction. Simple. You can't get around it. And like Adam said, and like I said with my second point, just think about this. Right? Even if they say, density grade the temperature, QE, which is stupid. If I'm looking straight out at something, let's say the black swan photo, if I'm looking straight out, I'm looking horizontally. Are there horizontal gradients?
Somebody in chat thinks so. Refute Flat Earth says that cold, dense air has different refractive index than warm air. Therefore, Snell's law will apply.
Yeah, you go on thinking that, you retard.
No, but it's an interesting rebuttal as to how you would measure that. So the way in which they do that is to, as shown in the diagram, use water or glass or whatever with warm air above it. And at that surface boundary between the two medium, yeah, you can demonstrate a refractive index because there's a surface boundary between the two mediums, the two different mediums. That surface is where the incident angle will change at that point. Now, you can do that with warm air. You can do that with cold air against another medium. That doesn't fit the definition of Snell's law to say I've got warm air and cold air. Where is the surface interacting? Where is that surface between the hot air and the cold air? Unless you stick a sheet of glass between the two.
Exactly. One. Yes. You're in.
They're
Go ahead.
Sorry, I didn't realize you were going to start speaking.
Yes, you did. Go ahead.
Well, I kind of just started speaking at the same time.
Just go ahead.
Yeah, okay. They have a problem because when you're looking straight out, then the density of air is about the same, close enough for what you can see, right?
Yeah.
But the temperature is also pretty much even as far as what you can see. So if you can see whatever 10 miles, then that temperature is about the same 10 miles away, and the pressure density of air is about the same, right? They're talking about cold and hot. The cold is up higher where there's less density. The warm is down close. The warmest air is close to the surface. So they're all over the place.
It doesn't matter anyway.
I know it doesn't matter, but it's still reality doesn't fit with what they need it to be.
They think
in that way.
Even that's even a category error. Like I said, that has nothing to do with Snell's law. Number one. Number two, there are no horizontal gradients, you booger-eating schmucks. Think about it. If you're looking at the Black Swan, let me pull the Black Swan up. 1 second. Jeez, oh man. You guys aren't going to see that in Discord. Just picture it. You know what it looks like. So if I'm looking out here, I'm at let's say I'm at 3 foot or 6 foot. Doesn't really matter. I'm looking at the horizon and see, I'm looking straight out. That's horizontally. Not vertically. There is no horizontal density gradient of air out to the horizon, you glue sniffing fungus munchers.
Well, Huey, technically, maybe there is some. The problem, though, hold on. The problem, though, is that whatever there would be so little over so much distance, if any, that it would always turn into insignificant, immeasurable little amounts.
It's nothing. Yeah, it's stupid on its face. So, A, let's continue. The married bachelor paradox atmosphere is only one medium, like we said. Get on up there. Damn. So you're toast right there. I mean, it's outside the parameters of the definition of refraction. B, the Dunning-Kruger numpty dipshit baltards only recourse? Tie Snell's law to a tree and feebly adulterate it with their Tootsie Roll dicks, after being found wanting and laughed at, snatch a baseball bat and proceed to Bob Euchre flail blindly at the demobilized damsel and invoke the married bachelor paradox curve gases. It's the only thing they can do. So you can't do that because you'd fail first grade intro to gas behavior, but they'll do it anyway because they have no honor. They have no dignity. You don't think so? Watch this little snafu. From the subject.
Yeah.
What?
I just want to go to one because that's what you've heard me interject at one point. I go, get a little bit excited. Yeah. But it's 1A, it's this A. Yeah? This is a paradox. It's the point I kept repeating. It's one medium. It's a surface change. Yeah.
Mm-hmm.
It's not, and this is the point. All you need to make to them, you don't need the science. It's not applicable.
Yes.
What you're claiming is happening. Yeah. 2 medium surface, yeah, is required for Snell's law. They're not claiming that. They're claiming 1 medium gradient change. So they can't use Snell's law and therefore the term refraction.
Exactly. Exactly, Adam, you got it. Let's head back. I'm going to show you what they do. They're going to Andrew Thomas Young from San Diego State University is going to Tootsie Roll dick adulterate it right in front of your eyes, folks. He's going to adulterate this right in front of your eyes. Watch how he does this. Snell's law, again from Andrew Thomas Young, San Diego State University, astronomy department. Listen up, folks. Snell's law gives the quantitative change of a direction of a ray of light in passing from one medium to another. The product n sine z is the same on both sides of a plane interface. Look at this, Adam. You see this? We're going to come back to this. That's not my point. It just hit me. I digress, folks. Let me go ahead and start over. Snell's law gives the quantitative change of direction of a ray of light in passing from one medium to another. The product n sine z is the same on both sides of a plane interface between two media. Uh-oh. That's a problem, and this is going to be a big friggin' problem here in a second. But I digress. It's not my point. Where n is the local refractive index and z is the local angle the ray makes with the normal to the interface. See the refraction page. Ladies and gentlemen, Andrew Thomas Young must give you this definition for Snell's law. Do you know why? Yes, because that's the definition of Snell's law. Now, watch what he does. He's going to adulterate it with his Tootsie Roll dick, like I said above. Watch what he does. Next sentence. In the curved atmosphere, Snell's law, presto magico, becomes nr sine z equals constant, where r is distance from the local center of curvature. See the page especially devoted to this refractive invariant. You mean refractive retard. Did you see what he just did, ladies and gentlemen? It's subterfuge.
Yeah,
He just train wrecked his above statement, which he had to say. He just imploded. This is a mind-numbing paradox within a paradox. Go ahead, Brian.
About to say, this is the mother of all paradoxes, this one.
Yep.
Yeah. This is his own intellectual paradox. Everything he's done and built up to in terms of his statements, the formulas he's derived, everything, and has been built upon a flat plane. Yeah, everything he's derived, everything he understands, all his understandings come from that flat travel of light. Then he makes the statement, however, given everything I've said and calculated and formulated prior to this, in the curved atmosphere, because he's not in a curved atmosphere, is he, when he's formulated this? But in the curved atmosphere, when I'm now living on a ball, Snell's law becomes.
Yeah, presto magico. This is not Snell's law, ladies and gentlemen. Because I just showed you what it was a number of times. That ain't it. He just conjured it. Like I just said, if you weren't paying attention, let me go back up here. B, the Dunning-Kruger numpty dipshit baltard's only recourse is to tie Snell's law to a tree and feebly adulterate it with their Tootsie Roll decks. That's what Andrew Thomas Young just did. After being found wanting and laughed at, snatch a baseball bat and proceed to Bob Uecker flail blindly at the demobilized damsel and invoke the Mary Bachelor paradox, curved gases. That's exactly what he just did. Within the same he did it within the same breath.
It's full of violation.
This debunks this. You can't make this up, folks. You're seeing it right in front of your eyes. I don't know what else to tell you if you don't see it.
How, if the atmosphere is not curved, how was Snell's law derived? See, if Snell's law is derived from reality of a curved atmosphere, then it is what it is. You don't need to take something you've derived from reality and apply it to reality, do you? It doesn't change, does it?
No.
It stays the same. That's the paradox. Are they his words?
Yes.
Does he? My God. So in a curve, he actually says that.
Yes.
Well, then that is the ultimate paradox and the ultimate intellectual failure of himself.
It's just it's retarded on its face.
It's like Ranty, isn't it? It's like Ranty coming and going, yeah, it's clearly curved. Look at that picture of Blackpool, the clock tower.
Adam,
Man.
Adam, there's more meat on this bone, and it hit me. Just hit me. I must have read this 100 times, probably more. Look at this. Watch this. The product n sine z is the same on both sides of a plane interfaced atom between two media. Where's the plane interface with gases?
Where's two media in a?
There's not.
And a mixture, a gradient change of air. There isn't, and that's why it's disgusting. him to make the statement that any of this is applicable in his curved atmosphere, yeah, is the lie. I use that word here genuinely because that's what he's doing. He's lying. He understands what Snell's law is. He's made the statements. He understands that even in his world, the atmosphere is one media. Yeah.
Yep.
Yeah, that's a lie from somebody of that level of knowledge to put that sentence together. That's why I said, are they his words?
Yes.
That's shocking, isn't it? Then, and why? Why would he need to bastardize his work that he took from reality to fit what? What's it fitting? Not reality.
He's just contradicting himself.
Yeah.
I wanted you to comment on this.
It's a plain interface. Well, that
between two media.
Yeah. Well, you can pick on the plain interface, which when if you're doing your little light things in a lab, physics, and you've got your convex and your concave surfaces, you're creating tangents at the point of intersection of your incidence angle. Now, there's ways of always. There's two media.
Yeah, it's a plane interface. I showed you a bunch of times with the diagram. Here's the plane interface, ladies and gentlemen. You see it? Plane interface. It's all over this. It's in every time you look up Snell's law, you're going to see plane interfaces in the diagrams. Where's the plane interfaces in the Atmo?
Also, how do you have a plane interface on a globetard?
You can't. That's another subject that you had to bring that one up. We can slope a dope on another day, Flatsy.
I'm sorry.
That's what they're trying to invoke. Multiple changing tangented plane interfaces, which is generated by a curved atmosphere and light traveling straight. So as the density gradient changes as you traverse, it creates a plane interface, and that's the main point of contention that I'll keep making.
I need I'm sorry, Adam. I'm sorry. I'm gonna need plane interfaces, horizontal plane interfaces in the Atmo.
Well, I was forgiving him that and saying you can create incidental tangents all along the path, and check, yeah. But there's still only one media, so I don't really care about that because it doesn't matter. It's one media, so there isn't anything to satisfy
There's
the
no
definition
interfaces. Yeah, exactly.
of
Yeah.
the interface. Yeah.
Well,
but
hold on. According to Refute Flat Earth, you don't need planes in Snell's law.
Oh, brother. All right, we're gonna move on from this. We're on to.
That's what I'm saying. You can invent tangential points of interaction.
No, we don't want to go down that road. They're tangential points. No.
Now, let me finish. That tangential point is theoretically a plane you create at the point of intersection. It's still the same thing. Yeah, you're just dealing with a curved media.
Adam, there are no horizontal. Adam, there are no horizontal plane interfaces, dude.
There is no media change. Be that media change a flat plane or a curved surface. There is no media change. That's the only point that's worthy of note to me.
All right, fair enough.
The definition requires two media, not a density gradient in one.
And even if it was a density gradient, it wouldn't be horizontal. So that's what they did. So what Andrew Thomas Young did was abracadabra, gonna reach out and grab you, pixie dust from the curved Atmo in Gondor. That's what he just did to you. Hope it feels good. So the booger-eating, ball-tard, tootsie-roll dick, shape-shift, delete, the quintessential tenet of Snell's law, two different isotropic media via substituting a paradox, curved gases, atmosphere, into Narnia, then presto, magico, voila, bagak, refraction. That's what he just did to you, folks. He thinks he can get away with it, too. Obviously, or he wouldn't have printed it. Fanatical, paradoxical, religious zealot retards. That's what we got here, ladies and gentlemen. I'd like to see him try to get out of this one. So somebody go get him and bring his dumb ass in here. One more tiny issue, lack of precision. I bring this up every time. I'll leave it with you. You make the decision. So let's do this. You've seen this definition before. Let's go over this. From the physics classroom, refraction is the bending of a path of a light wave as it passes from one material to another material. The refraction occurs at the boundary and is caused by a change in the speed of a light wave upon crossing the boundary. The tendency of a ray of light to bend one direction or another is dependent upon whether the light wave speeds up or slows down upon crossing the boundary. Okay, you guys got that definition, right? Everyone's seeing it. Hold up, Adam.
Boundary. Just boundary. I'm not being a dick. I'm serious. It's easy to say the boundary. Yeah. What is the definition of the boundary? It's not a density gradient. It's the transition between one material to another. That is the definition of boundary.
Yes, sir.
Yeah. Nothing else. Not
Yes,
the same
sir.
thing getting a little bit more dilute. That is not a boundary.
Yes, sir. That is correct. But in this diagram, I'd like to show everyone, listen, we have all the prerequisites for what they call refraction from this definition. We got two different materials, air and water. The refraction occurs at the boundary. We have the boundary. It's a plane interface, right? We have light coming in. The tendency of a ray of light, so we have a light wave coming in. We have everything needed for refraction. Guess what's happening here, folks? No refraction. The refracted ray does not deviate.
Got you. Got you. Right. So, yeah. Okay. So I understand now. Yeah. Because the actual calculation or refractive index requires a flat plane. Got you. I understand why you got excited earlier. Yeah. You can't do that without a flat plane. That's how you calculate it. It's the incident angle across a flat plane. So by definition, it is defined via its interaction on a flat surface. Like it.
I'm just saying, you know, I got what you're saying, Adam. I think. Is somebody trying to interrupt us? Oh, wait, somebody. What's going on?
Refracted curvatures, hot micing.
Hold on a second, folks. Can somebody mute him? All right, folks, I'm going to have to go move.
All right. I'll give you that. That was really cute.
I had to take care of that, folks. Sorry about that. Refracted curvature, you even told me you weren't coming in because you knew your mic was going to be a train wreck. Or your internet was a train wreck. Same thing.
His mic was fine.
His mic was fine, yeah.
All right. I think I get to get us back on track. I think I get your point, what you was alluding to earlier. Yeah. By the very calculation of itself, it requires that flat plane and the angle of incidence to change to calculate it as you intersect across that flat boundary layer. Can't do it on a wobbly curvy. You don't do these things. You don't calculate it on anything other than a flat boundary layer, do you?
I'll just leave that out there for everyone. That's a small, I don't know if it's a minor point. It's not one of my main points, but I found it interesting. You got another problem. To establish the efficacy of Snell's law, please show photons as friggin' waves. Why? Because in every single definition of refraction, it has waves. From their alma mater wiki, Snell's law, also known as the Snell-Descartes law and the law of refraction. We went over these before, folks. Sorry for the redundancy, but my points need to be supported. Is a formula used to describe the relationship between the angles of refraction when referring to light or other waves passing through boundary, right? You see that? What are you doing now?
Scroll back up. Why do they need this? I often pondered on this. Waves don't work very well in terms of angle of incidence. Go up to the one where you're coming just straight down. Right? Now that lovely, right? Waves schmaves, they're going to do something different at that boundary. In fact, they're bombs. They're individual things. They go straight down. The boundary layer makes no difference to the trajectory. If I fire them in at different angles, if it's just like ball bearings, I know what's going to happen. They're not going to carry on the same trajectory, those individual particles. I've got no need of waves to comprehend that.
They don't have waves anyway.
I know, but what I mean, sometimes it's easier to imagine things as a wave, the whole complexity as a wave pattern, how it resolves. Certainly in terms of refractive index, I find it much easier in terms of particles. It works much more sensibly as a particle.
It would have to. But they got big They got big problems, Adam.
Fundamentally, because it is.
They got big problems. Like I said, I'm going within their own paradigm. Their own subject matter experts are contradicting each other. And that's the reason why I said, well, to establish it, you have to show friggin' waves, because waves are all over these definitions. From the physics classroom again, refraction, where do we find? Ray of light, light wave, wet light wave, 3 times in this section. Rot-row, Shaggy, you got a big problem. Why? Because Richard Feynman and the chair of physics at Yale tell you that light's not a wave. From Richard Feynman, the first thing Newton believed light was corpuscular. Turned out that it had very strange properties from that point of view, and it was then explained that many of these strange properties were because, in fact, it was a wave, which was wrong. Turns out he was right. It was a particle. Uh-oh. From the chair of physics at Yale, Professor Shankar, everything is really particles, all things, electrons, photons, protons, neutrons, they are all particles. So let there be no doubt about that. That's some pretty strong language right there. He must know something. What I'm saying here in pointing out that there are contradictions paradox embedded within their own paradigm. These guys are baltards. The same as Andrew Thomas Young. Where are you getting the waves at? They're calling light a wave. No, it's not. But you need that for your fairy tale refraction. So, show photons as friggin' waves. Anti-flat earthers. Best wishes. You like how I did that, didn't you? Yeah, you better like it. Number 4. To invoke Snell's law, you must know the one-way speed of light. Why do I say that? Is Brian still in here? He's gonna chime in and pipe up. Oh, so why do they need?
I was waiting.
Was he just waiting?
Let's give him a second. He might be struggling to get to it. Come on, you can't say that without Brian.
I don't want him to interrupt now, but he's going to interrupt at the end of it. So, 4, okay. Like I said, again, to invoke Snell's law, you must know the one-way speed of light. And you say, well, why is that, QE? I'll tell you why. Because refraction is defined everywhere you look by a change in the speed of light. So how do you evaluate the speed of light when you don't know it? From Hyperphysics, Georgia State University, refraction is the bending of a wave. Here we go again, another wave. When it enters a medium where its speed is different. Different from what? That's what I said right here. Speed is different from what? To calculate the difference between you must know the one-way speed of light. Not going to happen. It'd be easier sprouting Japanese maples from your armpits to know the one-way speed of light, folks.
This is what does my head in, right? That explanation. The reason the angle of incidence changes is because there's a change in the speed. You take your throttle off your car. Do you go in a different direction? No. Right? If you plow into water, right? You move, don't you? You 2 things happen. Your direction changes because the medium you're in has changes, and your speed changes because you've gone into a more I don't like I say I don't profess to understand that. I have my own understanding, but back in the day I never understood that explanation. All right, I've slowed down. Well, why am I going in a different direction then? Yeah, that's not an explanation of the angle of incidence change.
Nope. Now, I did caveat this. First of all, shout out to Betty. As you noticed, Betty, I didn't use broccoli this time out of your armpits. I used Japanese maples. Hopefully that's better. And I'd like to caveat this. if they're comparing two convention speeds, then I may relent on this point. Keyword, I may relent. But in actuality, objectively, they're screwed.
I think
Yes?
I just did relent on that point because it's kind of irrelevant. If you want to invoke different speeds as they're going through the air and then the glass, whatever, I don't care. Different, fine, lovely, makes sense, covered. Has it gone in a different direction? That's what I'm asking here. That doesn't explain that.
Nope.
They can have it. It's kind of irrelevant again because what's required? Have two different speeds in two different media. You need two different media.
Yeah, you do. And Adam, we're getting up to your favorite, number 5, and you
See
just
number 5 creeping up.
you just rumpus the whole damn presentation, and now we're into 5. You're just gonna go off, aren't you?
I'm going to be so quiet, it'll be strange. I think.
Yeah, right. You will. You let me finish, and then you can have your way with her. All right.
Be a good boy.
All right, number 5. Even if we play Be Kind to Dumb Animal Ball-Tard Booger Eater Week, granting them all the married bachelor paradoxes. Let me remind you what those paradoxes are, folks. There's 5 of them. Curved gases, Snell's law, Tootsie Roll Dick adulteration, the waves catastrophe, the one-way speed of light, and Bubby Baruni's fairy tale radius value. If you can count, there's 5. Right? The Snoz particle chefs are still toast. It's a difference without distinction. They're booger eaters. There is no 5 times paradoxical refractive phenomena that takes the geometric horizon that they don't have and jettisons it 10 times farther than it should be. Now, I'm going to point it. Just give me a few minutes and I'll get to that. It's going to be a whole lot of fun. I'm going to show you this in spades, just not right now. Okay? Just remember I said this, right? Kablooey spinning space monkey surfers. Now it's going to get fun. P.S. 5A, baby. Rays. Where's Ray? Let's find out where Ray is, shall we? This photo's pretty cool. It doesn't look like a photo, though. It looks like a painting. But I digress. So let's check this out. From Andrew. No, this is from Andrew Thomas Young. This is from Hyperphysics. We'll get to Andrew, subject matter expert, right here. He's got some splaining to do. He's going to try to explain it in different ways in different documents. It's going to be hilarious, folks. So, and I know we've seen these definitions before. Just entertain us. Humor me. Refraction is the bending of a wave. Yeah, that's hilarious. When it enters a medium where its speed is different. That's pretty funny, too. The refraction of light when it passes from a fast medium to a slow medium bends the light ray. You see these rays? They're all over the place in these definitions. So we got a ray right here, and then down to the subject matter expert, Andrew Thomas Young. The way he defines it, remember we brought this up, this train wreck of a monkey disaster? But in his definition, he's got rays everywhere, doesn't he? We got a problem. Andrew Thomas Young, because like I said, in the next document, this is what he states. Listen to this closely, folks. This is going to go back to the horizontal gradients too. Listen to what he says. Some people have worried about how to apply the refraction law. Why are they worried? Number one, maybe they're worried because of this. Or the 5 paradoxes that I just mentioned. Maybe those, but I digress. Check this out, folks. Some people have worried about how to apply the refraction law to a horizontal ray of light. This is really important. Because it does not cross any horizontal boundaries, folks. This is what I was talking about above. Horizontal density gradients. I know we're on the rays, but this is going into horizontal boundaries and to plane horizontal interfaces. From denser to less dense air in a stratified atmosphere. Yeah, your stratified paradox is stratified vertically, not horizontally, Holmes. You dumbass cracker. But I digress. Let's get back on rays. Listen to this, folks. He's saying rays. Everyone's saying rays. He just said ray above. And in his own document, it's a different document. Listen to this. In general, the curvature of the ray is different from the curvature of the Earth's surface. But here we are only concerned with rays that bend just enough to follow the curve of the Earth. You can't make this up. Here comes the rub. The simplest solution to the horizontal ray paradox. Now listen closely. He's not giving you a solution. He's giving you an admission of retardedness. Listen to this. The simplest solution to the horizontal ray paradox is to remind ourselves that rays that's spoken about in all their definitions are an unrealistic mental construct. In reality, we always have a beam of light. Infinitely narrow rays don't really exist. So how are they describing a phenomena in all their definitions with rays in physical reality and have them not exist in reality at the same time? How you like that? 1 second, Adam. And then he goes on. And hold on a second, Adam. I'm gonna scroll back up. And finally, in a completely separate document, he confirms it again. In the diagrams below, heavy lines represent rays of light. If you are not familiar with this conceptual fiction, please check the Optics for Beginners page before continuing here. He's speaking to you, anti-flat earthers, because you need to go back and check the Optics for Beginners because you're numpty dipshits. And we've just blown this whole thing right out of the water. What's the word I'm looking for? I give the floor to Adam Meakin.
Thank you, Zach. That last bit, he almost redeemed himself because he's like satanic law, isn't it? They have to tell you the truth, yeah, because he's telling lot. Not familiar with this conceptual fiction. Everything he's just taught you, yeah. Please check for Optics for Beginners page before continuing. I mean, that is brilliant sarcasm. I like that. I really like that as a sarcastic way of saying, if you don't get, I'm just blagging you. Yeah, you're a retard. Go back to page 1, you muppet. Anyway, I've not seen that before. It's almost as nice. This bit I love because everything I've just banged on about is the Pope, like, castigating Catholicism. And none of it's real. None of the sacraments that we made are actually real. It's just our stuff, so that you can understand it. And I'll stay away from Catholicism. I'll draw it back to the sacrament is a ray. Yeah, so fundamentally denies the ray, the thing is used to describe everything to you. But the bit I like is I don't care about that. It's like you can work your head around a ray. He's denying what? He's denying this medium change, yeah? Because it does not cross any horizontal boundary layers between denser and less dense air in a stratified atmosphere. He's taken away what the anti-flat earthers invoke. Yeah? That's what they're trying to claim, even though, as we've demonstrated, that's got nothing to do with Snell's law. He takes it away. Yeah? And then, final bit, again, it's a little bit of kudos to him, or is it really? It's a bit like Hans Fritzl, isn't it? You know, when you've got your sex slave in the dungeon after you've done whatever you've done, then you're kind to them and you give them a bit of a mental plaster and you go, don't worry about the ray raping you've just suffered mentally. I know you're struggling. Just realise it's okay.
It's funny.
These don't exist.
It's
These
funny.
don't really exist. That's the point he makes.
Dude, how can you bring sexual slaves into this?
Because that's what's happening. That's exactly what's happening. You're being... Don't worry. the Disney Channel.
I'm going to stress it again.
Stratified atmosphere, but he's still making the statement. Doesn't cross any eyes. Yeah, he can still stratify the atmosphere, but he's still saying it doesn't exist. There's no, and this is there's no boundary layers. There's no surface. A compliment somehow.
All right. Let's now take paradoxical terrestrial Narnia refraction to its logical ends. Let's do that. And practically demonstrate what happens when you extrapolate from a multi-layered, paradoxical, adulterated, fictional, foundational fairy tale. Let's go ahead and do that. Let's have a little fun, okay? So, from their alma mater wiki, atmospheric refraction near the ground produces mirages. Such refraction can also raise or lower, stretch or shorten the images of distant objects without involving mirages. That's a little preamble to get you greased up. Now we have wiki again. However, this time it's cited number 1 and number 2. Number 1 is the weather doctor, and number 2 is our favorite guy, Andrew Thomas Young from San Diego State University Astronomy Department. I want everyone to pay attention now. Get the Adderall drip out. It's not going to take too much. You can just drip it. You don't need to central line it. Okay? Listen closely. While mirages are the best-known atmospheric refraction phenomena, looming and similar refraction phenomena do not produce mirages. Mirages show an extra image or images of the mirage object, while looming, towering, stooping, and sinking do not. Now, there's 5 of them. There's 5 fairy tale atmospheric refraction types or effects. Count them with me. 1, a 2, a 3, a 4, and a 5. Everyone got that at this point? Good. No inverted image is present in those phenomena either. Depending on atmospheric conditions, the objects, that's going to become very important here in a few minutes, can appear to be elevated or lowered, stretched or stooped. These phenomena can occur, changing the appearance of different parts of the objects in different ways. Sometimes these phenomena can occur together with a true mirage. La-di-da-di-da. So everyone got that, right? Let's go over it again. There are 5 effects of refraction, according to Andrew Thomas Young, subject matter expert. Let's do them again. All 5. Mirages, towering, stooping, sinking, looming. Let's now apply each to the black swan photo and evaluate their effectualness. Let's go ahead and do that. So, guys in Discord, you're going to have to picture the black swan photo. I'm sure it's not hard for you. Okay? Out there in YouTube land, they're looking at it. We're going to take each one of these monkeys and we're going to see if they apply and evaluate their effectualness. How about that? Logically follows. So, mirages from above. Mirages show an extra image or images of the mirage object. My question, in the black swan photo, is the horizon miraged in this photo? Is there an extra horizon or horizons in this black swan photo? No. Nope. Non sequitur. Uh-oh. That's 1 down. Let's do 2 and 3 together. Towering and stooping. From above. Towering and stooping change the apparent shape of the object itself. With towering, objects appear stretched. With stooping, objects seem to be shortened. Question. Is the horizon changing shape? I.e., is the horizon stretched or shortened in the black swan photo in front of you? Nope. Non sequitur. Laughingly so. You're running out of choices. You only got 2 left there, Baltards. Let's try sinking. From William Jackson Humphreys, Physics of the Air. Sinking. Sinking is the opposite of looming. In sinking, stationary objects that are normally seen above the horizon. I digress here, folks. Do you see the compare and contrast, the juxtaposition between objects and the horizon? Do you see? It's a relationship between these 2 monkeys. The horizon's not an object. They're Rhodes Scholars. But I digress. I'll start over. Sinking is the opposite of looming. In sinking, stationary objects that are normally seen above the horizon appear to be lowered or may even disappear below the horizon. That is, the objects in relationship to the horizon there, Baltards. I got a question for you. Is the horizon lowered or disappeared below the horizon in the black swan photo? You heard me. Is the horizon lowered or disappeared below the horizon in the black swan photo? Nope. It's retarded non sequitur. You only got 1 left. Guess what's going to happen? Looming. I've asked Baltards what looming has been for 8 years along with refraction, and no one has ever given me this definition. I wonder why. From the subject matter expert, Andrew Thomas Young, San Diego State University, Astronomy Department. Listen up. Looming, the appearance above the horizon of a distant object. We got the same phenomena again. We have a definite distinction between object and what it's doing in relation to the horizon, don't we? But I digress. I'll start over. The appearance, looming, the appearance above the horizon of a distant object that would normally be hidden below it. This is my question. Is the horizon appearing above the horizon in the black swan photo, shaking my fucking head? Let me ask you again. Is the horizon appearing above the horizon in this photo, please?
Imagine this on your resume. A certified
Non sequitur from the Black Friggin' Lagoon. So, the friggin' horizon doesn't ever loom, ass clowns, even in your own paradigm, which we just train wrecked above. Ever, ever, ever does it loom. Baltards wouldn't know what Bagak refraction was if it climbed up their arse and started kicking footballs wrapped in Carolina Reaper lace concertina wire. And I just demonstrated it in spades over and over and over again. The end. Questions, comments?